So a while back I did a video on these DYS flight controllers right here and how the accelerometer on them was broken or having some issues, and I went through a process where I desoldered it and put a new one back on, and it worked, and so that was pretty cool. I thought that was pretty neat. Well, over time, so I don't know how long that's been. It's been probably 2 or 3 months since I did that video. We've ran into at least 3 more that has had the same problem. And what I figured out since then is that first original one might not have actually been a bad accelerometer. What I believe is happening is just from poor soldering at the on the pick and place or however they're putting it together, that it didn't get the joints didn't get flowed very well. And so all I do now is let me reach over here, take your hot air rear workstation and just heat this thing up until you start seeing everything cooking, take it away, and 3 out of 3, or however many it's been so far, I do that, I let it go, or I take the air off, let it cool down, comes back, and it works fine. So if you happen to have that same problem, this might be kind of a good fix for you if you're really bummed out that this new flight controller you got isn't working and you're going to send it back. They're going to refund you, but you don't want to wait the time. Maybe you could try, heating this up. Now, there's no legs on here because they're basically folded underneath, right? So it's kind of hard to get at. It's not a BGA, a ball grid array, so it's not as hard as that, but still, you can't really get at it with a soldering iron. So you need to have hot air or possibly a really hot toaster oven, right? But try that at your own risk. So that's a thing. Now, the next thing though that I wanted to talk about was, since then we have had another issue that is, it's basically user error, but here's the one of the roosters here, and it has to do with the newer location for the ESCs. So what they did is they moved, see if I can do this with just my thumbnails here. They moved the ESC pads to right here above my thumb and over to here, and it kind of got it sort of out of the way. It was sort of problematic before, and now this is a little bit better, but I'd still say that there's still some issues because, I don't know, everybody's trying new stuff and that's cool, so we roll with things. But you've got this pad right here. I mean, you get the little rubber shock pad, and then you've got your nut right over the top here. You solder these pads and you get a little blob going on right here. Then you have to solder these guys in here, and that's kind of rough for some people, and that is what it is. But what ends up happening is now you have this pad right here with a blob of solder and the things running around the side, and you end up with this right here. So what's the problem with that right there? Well, this is power, and when you plug a battery into this, that gets power immediately, and it happens to be right next to this. And what is this? Well, I mean, yeah, it's the USB, but this is the ground for the USB. So let me put this down here. Now I take my USB cable and I plug it in. Then I take it out and I plug it in, I take it out, and I'm going to beta flight, try some stuff. I do my ESC, so then I got to plug my battery in, so I go ahead and do that. Take this out, put this back in, and you're trying to be careful, but you're doing this back and forth, and then 1 minute you're not looking so close, and you go to shove this in here, and you touch it like that. What do you suppose is going to happen? Well, it kills the board. Well, not exactly. I mean, it kind of kills the board. So what happens is you hit this, it sparks, and then what you find out is you plug the cable, you plug the battery, take the battery out, you plug the battery back in, and it looks like it's working fine. But you go to plug the USB back in, and you get barely tiny flickering little light in here, not the normal lights you're supposed to have, and nothing up on beta flight. It doesn't work. The USB is dead, and you can't use it anymore. So it's a big bummer. I'm not real happy with that position right there, but it is what it is. I'm not going to cry too much about it because we're all trying new things. The board manufacturers, the people are trying different things. So there's that. What I would highly suggest, though, is that you take this spot right here and you do something with it. Cover with something, get a bunch of hot glue or something, and just squirt the crap out of it. Cover this, shield this, so you can't let that happen, because we've done that twice. I did it myself. Somebody else did it as well. I'm sure that some of you out there have done that. You know, it's just, you know, it's real easy to do as you're going back and forth and back and forth. So watch out for that. Now, I will mention this, though, that be careful and do some research on this and just kind of, you know, go a little bit, do some due diligence, I guess. Check the conductivity of the potting material that you use. So if you use hot glue to cover something up like this, I can tell you it's probably going to be fine. But do the research to make sure that it is not conductive, and it's not conductive with a little bit higher voltage, because everything can be conductive, and creepily enough, some things that are not conductive at all become conductive over time as they dry, cure, get hard, or whatever else happens, right? So watch out for that. We've seen similarly where right back here at the input power lines, where people were soldering all this on and they didn't clean the board off. You know, get yourself, you know, something, isopropyl alcohol, right? Clean everything really, really well, because the flux that has become carbonized created a bit of a circuit, and you start having some things sizzle up there. So be careful of that. All right. So having said all that, I thought I would, you know, since I you know, did okay with resoldering the accelerometer gyro on there, why not take a peek at it, you know, because I was thinking, well, it's USB and it's ground, and, you know, man, that's going to just go all over the place. Who knows what it's going to kill. And, you know, I find that this is kind of a thing that happens. You just like, ah, screw it, you know, I can't figure it out. Well, you look at it, and you look right here, and you see, where's my little poker stick? So you start looking around, and you're looking for anything that's wrong, you know, anything noticeably fried, and there's nothing fried, and you're like, yeah, I don't know, you can't figure this out. Well, hold on, let's just keep taking a look. So you turn it over, and as I turn it over, pretty much right off the bat, you look, and you see, you try to figure out where this thing goes to. You flip it over here. Sorry, I keep bonking the camera. And it comes over here, and then you start seeing that there's some traces that run up here. And as soon as you actually look, this resistor right here is totally smoked. And I look a little bit closer, I can see that it looks maybe like the traces burned out, like the coatings kind of burned off it a little bit. Turns out, after you clean it up, all it was the resistor, right? So I figure I'll just swap that out. Now, I'm imagining most of you probably don't have a bunch of surface mount resistors laying around. You can get yourself a little book like this from Adafruit, see right there. And inside, and again, you probably don't want to go get this. They're, I don't know, 30 bucks or something. But it's a little booklet of a whole bunch of surface mount resistors. These are 0805s, and they're pretty tiny. If you look right in here, that's where the resistor is there. So I took a 0 ohm resistor, the first one in the book here, and, well, I can't show you that with all this crap here. But anyways, the 0 ohm resistor is pretty much perfect for just this kind of thing. It's almost like you're creating a fusible link with it. You put it across here, it's the same as jumpering it. Think of it that way. It's just a surface mount jumper. So I put it across, and guess what? Lo and behold, it works fine. So what I want to do is a couple things. This one was the one that was dead, and it now works again. So there's that. This one here has that problem, and I want to take this stuff off here, and let's look together, and we'll see if it's got the same issue or not, and if we can fix it. Then the next thing I want to do is, that's cool. That's cool that the 0 ohm resistor fixes it, but you know, and maybe it probably doesn't matter, and I could let it ride as it is. But I'd kind of like to see what it is. So this one here is a good one, I believe, and, well, a good board. I'm going to pull this resistor off so I can test it. We'll see how much impedance this thing has, and then I can find the right one in the book, and then I can take out the one that I put in, I mean, if it's massively different or not, you know, and swap it out for a proper fix. Okay? So I figured that would be helpful. Now, if it turns out that it's a really low impedance resistor or something like that, you know, maybe then if you've got this same problem, and we're talking about quads that have somewhat of a, you know, limited lifetime anyways, just grab a piece of wire and just solder it across there or something like that, right? You could even get a regular old big fatty old radial resistor and just stuff it on there some way or another, right? Just to get yourself going again. All right, so let's get started, and we'll see what's up with this guy. All right, well, for the sake of transparency, that was actually the wrong rooster. This is the one that has the problem right here. So if things look a little bit different, I'm not trying to play a fast running, I just grabbed the wrong one, which, you know, isn't that a nice problem to have? So what I want to do is I want to see how little I have to get off of here, take off of here, so I can get underneath there. So probably maybe just desolder this side here, and maybe I can just roll the thing over. Actually, I guess I could just undo everything here and take the motors off and then flip the whole thing. That might be the easiest. Well, here we are. It does look like it's exactly the same. So you can probably see right here. We'll zoom in a little bit. Now, it does look like there's a fair amount of burnt all around in here, but we'll get some alcohol, we'll clean that up, and we'll see what it looks like after we get all the crud out of the way. Okay, well, I want to be careful now this is all loose. I want to make sure nothing's actually touching anything it's not supposed to be. Remember, by the way, carbon fiber is conductive. There we go. So this is what you see. Now, did you hear that up there? It blinked. Hold on, let me get you over here quick. Okay, USB device not recognized. So it sees that we plugged it in, but it doesn't know what the hell, right? And we're getting just this little light rather than all the rest of them that we normally should be getting. And if we look up here, Betaflight's sitting there not doing anything. This is going to be kind of weird. I'm going to try to desolder this with the camera right in front of my face and me trying to peek around it here. And I'm going to, I feel like I probably would normally want to just do this with the hot air rework, but I know a lot of you don't have that, so I'm just going to try to do this with the soldering iron and see how this works. I mean, I know this works, do it all the time, but it's kind of weird behind the camera here. Trying to see if I'm still in frame and getting a hold of the damn thing. I'm going to try to grab it, heat it, lift it, move it. I don't want to rip the pad, you don't want to do that, but you want to heat both sides enough. Actually, I'm going to get a little bit of solder on here to help the thermal contact. Oh, and on top of it, it's most assuredly going to be lead-free solder, so you want to kind of intermingle some other solder with that and life will be better. There we go. So again, where's the camera? Let's do this. Okay, there you go. There's the little resistor. Inky tiny. So set him down there. And I'll get some solder wick and kind of clean that up. Okay, I think the pads look okay. Let's get some alcohol on here. If we get right in here, it looks really good. I was a little bit worried about this guy over here. It had some burntness on it, and this one over here, and it kind of looked like maybe it had burned into this tracer, but looking through it right now, everything looks fine. Good sign. So here's the other good board. We didn't just jump in time and I threw the thing in there. This is a working board, and now I'm going to remove that resistor, take it off so we can test it. In case you're wondering or don't know this, we can't test it in circuit because there's too much more of the circuit going around here, and we might, where's my friggin' pointer? We try to probe it and we might get resistance from who knows where, right? So we got to pull the thing off and then we can test it. So this little guy right here is a 0 ohm resistor. I'm not getting anything on this. So, well, I mean, I'm getting like 0.2 ohms. So that's, uh-oh, it's going now. Effectively a 0 ohm resistor. Okay, so let's go ahead and there we go. Try to get the other one back on. Can't get a hold of the damn thing. There we go. Left-handed, upside down, over a camera. Jesus. Straighten you out there. Jesus. Okay. That'll kind of work. Oh, that's a blob. Okay. I'm going back to the other side. A blob. See if I can get this to sit down a little bit better. Okay. See if I can clean that up. There we go. Okay, let's give this a try. So I wasn't going to put the whole thing back together, but I did want to make sure that all the wires were managed so nothing gets shorted out anywhere. Here we go. Don't do that. Woot! Well, yeah. Score. 2 for 2. So we're in. Accelerometer's working. Lights are blinking. So, there you are. the 0 ohm resistor that's there by default is doing exactly that. I mean, it's a protection most likely, so it popped. You just replace it. So that is all. If you're looking for 0 ohm resistors, I mean, they're less than a penny probably. If you want to go to DigiKey, you can find them. If not, you know, you can just bridge the gap again with a piece of wire. But the nice thing about the 0 ohm resistor is if you do that again, it will blow the resistor up again, and then you just change it. So go to DigiKey, spend $1. DigiKey has always prided themselves on this fact, and I believe it's still true because I buy lots of stuff from them in very small quantities, that they will sell you theoretically 1 resistor if you want it. Okay. So that's all. That's it for my video there. That's a pretty, again, anticlimactic finish, I guess. You know that it just works. As a side note, I heard recently, second-handedly, so you know, I don't know, you know, how true that information is, but some people out there have been having some problems with ESCs not working right off the bat. It might be a similar issue. So if you're having any problems with something dead, you know, on arrival, take a look at it. Maybe just try soldering some of the components again, and maybe you'll get it to go again. So that's really cool. I'm really pleased that these are built well enough that that they have that protection in there, and it's relatively easy enough to fix. So I hope you found that helpful, and remember, pot those things up, cover those things up so that doesn't happen to you. Thanks for watching.